Okay, so we have parallel lines. And this paper, we're assuming the lines are parallel. Okay, and parallel lines cut by a transversal. And so we're going to identify the relationship, and then we're going to write an equation. We'll solve the equation, and then we will use our solution to go back in and find the angle measures through substitution. That's it. So let's look at the problems we've been given here. In this first picture, I look at the angles here, and I notice that they are, when I put them together, the two angles would make a line or a straight angle. That makes them a linear pair. And as I look at the picture, I know, one, I should know that a linear pair means by definition that they're supplementary, but I should also be able to tell that they don't look equal. Like the two angles don't look like they're the same size. So I know they're not congruent. They are definitely supplementary. So here's how I'm going to write my equation. Angle, so this angle here, 8x plus 1, plus the other angle, 4x plus 11, equals 180. So when they're supplementary, it means the two angles added together equal 180 degrees. So that's how I write my equation. Now to solve this equation, it's not simple yet, so I have to simplify it so it's just two steps. So I'm going to combine like terms. So I'm going to put my x's together. When they're on the same side of the equal sign, I can just add them together. So 8x's and 4x's is 12x's. Plus, and I'm going to put my constants together. I'm adding 1 and I'm adding 11. So I'm going to add them together to get 12. So now I have 12x plus 12 equals 180. So solving this is simple. It's a simple two-step process. Subtract the constant. I'm doing this in my head, so I hope I'm right. Subtract the constant, divide by the coefficient. So divide by 12. So that should be 14. I'm pretty sure. I'm just writing it. So I'm just thinking about it as I'm writing it. So that should be 14. So x equals 14. Well, let me see if I did it right. Here's how I check. I'm going to put 14 in for x on both of these angles. I'm going to pause and do that. You try that on your own. So when I substituted in 14 for the x, on the obtuse angle, I had 113. On the acute angle, I had 67. Is that good? I mean, does that help? Well, yes, because if I add them together, they equal 180, and that's what I want them to equal. So there you go. So let's look at this last example. So the relationship here, I can already tell they're both obtuse. So I know they're going to be congruent because they're both obtuse angles. They're on the opposite sides of the transversal, and they're on the exterior. So these are alternate exterior. And alternate exterior angles are congruent. So my equation is whatever's, and I'm going to always pick the one with the greater coefficient to go first. So 4x is more, they go first. So I'm going to write 4x, just makes it easier. 4x minus 5 equals 3x plus 25. So let me pause that, and then you can come back and you pause it, try solving it, and check back with me. So this time, I couldn't combine the x's because they're on opposite sides of the equal sign. So I have to start solving. So I subtract 3x from both sides. So I only have x on one side. 4x's minus 3x's is just 1x. So x and then minus 5 equals 25. Then to solve that, I added 5 to both sides. That's the pink. And that means the x is by itself now, and 25 plus 5 is 30. So I don't have to divide this time because it's 1. So I just take this 30 and I put it back in. And I noticed that when I substitute in 30 for both of those expressions, the result is simplified as 115, which is good because they're supposed to be equivalent. So both angles equals 115. So there you go. Those are the 4 examples. Thanks.